these quizzes continually amaze me. I was under the impression that you guys would do really, really well on numbers 1 and 2, considering, I think it was the last quiz or the one before that, we had the exact same 2 questions to lead off the quiz. So I felt it would be pretty easy. And then I felt that there would be a lot of struggles on number 4, but I thought number 3 wouldn't be too bad. And a lot of kids wound up getting number 2 wrong and number 3 wrong, and more got number 4 right than I thought would get number 4 right. So I am continually amazed by how wrong I can be with some of these things. All right, so first one here, we want to find the zeros or the roots. You have to reverse the roots, which means that in the package it says x minus 5 and x plus 6, because then when we make them equal to 0, we would do the opposite to get them to the other side. So choice 1 is 3, and I think virtually every person had that right. This one, guys, when you see that a new function is formed, which is the old function minus 2, it's in a parenthesis. That's horizontal shift. We go 2 units, always opposite direction, 2 units to the right. Every point goes 2 units to the right. Part of every point is the vertex. So if this is 2, negative 1, and I move 2 units to the right, it becomes 4, negative 1.
I just forgot to add the negative.
So there we have that. Any questions about number 2? Okay. I do want you to develop the thinking about this horizontal and vertical shift and thinking this way, because you will see 1 or 2 questions on your Regents exam about this. You have to be cognizant of it so that you can recognize it when it happens. Okay, number 3. This question I thought would be pretty easy, yet a lot of kids got it wrong. So, and I do think a part of it is that our last lesson on this was last Tuesday, and then we broke off into pre-tests. But again, I don't care, because we get tomorrow's quiz and a quiz after this. All right, look, here's the general format. Any term, f of n, will be the first term plus, and maybe I should write a sub 1 there, plus the common difference times n minus 1. But it's the very first term plus the common difference times n minus 1. What's the very first term? 9. Now, the reason for the n minus 1 is because I want the 25th term. But I only add 8 24 times, because I don't add 8 to get to the first term. So that's why it's n minus 1, which becomes 24. And then the common difference is 8. And if you do that math, 9 plus 24 times 8, you get 201. Okay? And then over here, again, maybe I should call this a sub 1. But it's the first term any way you want to look at it. This is going to be 7 times the common ratio to the n minus 1. Now, the common ratio is found because this one you don't go up by a constant amount. It's not arithmetic, it's geometric. Divide 14 by 7 to get 2, 28 by 14 to get 2. So this common ratio is 2, and I want the 10th term, so 10 minus 1 is 9. 2 to the 9th times 7 is 3,584. Okay.
What is that next to the a sub 1 times?
R,
Oh, that's an
common ratio. Okay. Any other questions on the quiz? Yes?
Could I did number 3 a different way?
There are other ways to do it for sure. I certainly hope you didn't list them all out.
No.
Okay.
I did that for number 4, not number 3.
Yeah. The idea, I think it's best to understand how to find any particular term by using a formula where you take the first term, you do the common difference times n minus 1, or you do the first term with the common ratio to the n minus 1. I think that's the simplest way to do it. It's possible to do it other ways, but the bigger the number they're looking for, like if this said the 259th term, the better you are to go off with some kind of a structured way of viewing it. Okay?
Yeah.
Any questions? Yes?
Alright, so what does a to 0 mean? I mean,
It's the first term.
Sub-0.
First term.
First term, okay.
Yeah. And I think maybe I should have written a sub 1. Some formulas use a sub 0, some use a sub 1. Either way, just remember that what I'm talking about here is the very first term. That's why I put in the 9. Okay? Any other questions? All right. So, time to look at the do it. Boom.
Come on.
All right, so, consider the sequence generated by the formula. F of n is 6n minus 4, meaning the fourth term is the 6 times whatever term number you're looking for. In this case, the fourth minus 4, starting with n is equal to 1. So let's generate that formula. If I plug in a 1, what do I get?
2.
You get a 2, very good. So, the first number, you okay there, Alice? All right, we'll slamming your head into the desk. I just saw you go. You see Monty Python and the Holy Grail in the middle when they do Gregorian chant, or in the beginning?
Oh, yeah.
You know what Gregorian chant is?
No.
It's a form of like sacrifice.
It's like the first musical singing, and
And
the monks were
sacrificing.
walking around with the placards going, home. That kind of reminded me of that, except I thought you were gonna puke. Okay, so, f of n is 6n minus 4. Good. Plugging in a 1, Jeff is absolutely right, it's 2, because 6 times 1 is 6, minus 4 is 2. If I plug in a 2, 6 times 2 is 12, minus 4 is 8. 6 times 3 is 18, minus 4 is 14. 6 times 4 is 24, minus 4 is 20, and 6 times 5, let's do it another way. I'm
26.
going up by 6s,
26.
26 would be it.
Hey,
So there's my first 5 numbers in the sequence or in the series. Any questions? Okay, next up. 1, 2, 3, 4,
How many?
5, 6, 7, 8, 5, 9, 13, 17, 21, 25, 29, 33. Okay? Write a function rule. F of n equals. The more I think about it, I really can't remember if it's a sub 0 or a sub 1. I'm going to go with a sub 1 this time. It's the first term plus the common difference times n minus 1. So in this particular case, it would be 5 plus 4 times n minus 1.
Oh.
F of n equals.
Okay.
Okay? Yes?
I was just gonna write y equals 4x plus 1.
Yeah.
And that's a possibility too, if you look at it from the perspective of y equals mx plus b, because you look at it as a linear sequence. If I go back to 0, this means I need to go back 4. 0 pairs up with 1, which means b is equal to 1, and the rate of change is 4. So y equals 4x, plus 1. And if you notice here, if I distribute the 4, I get my 4n, and 4 times negative 1 is negative 4, and 5 and negative 4 make 1. So the two formulas are equivalent, and both deserve credit.
Alright, so.
All right, and you should be able to recognize both, because they will put them on multiple choice, and then you have to see which one is where. Now, the one thing about multiple choice is that you could always just plug in every value and see which one checks. Okay, so it kind of makes it a lot easier when it's multiple choice. Any questions? And also, if this was not multiple choice, I would fully expect that both answers would be given full credit. Okay? All right, so,
Would they ask us for both of them?
possibly, I really don't know. I put absolutely nothing past the state of New York on this Regents exam. I have seen questions that I just shake my head and say, you've got to be kidding me. So, not enough to make kids fail, but enough to make it very difficult to get a 90. All right, consider the sequence, 5, 8, 11, 14, 17. If you believe in patterns, you don't, one or two people recognize it. All right, what might you say the next number in the sequence is?
I might say it is 20.
20.
I said the next is 5.
Ah. Oh.
And then it could be 8, 11,
Five,
14, 17,
11,
5,
14,
8,
17,
5,
14, 17, 5, 8.
Continue for as ever.
Okay, all right, okay. But you said 12, didn't you?
No, I said 5. I said,
Oh, I said 5, okay, I thought somebody said 12, that's why I said repeating, I don't get it. Okay, now, I don't remember who Achille is. I'll kill you. No, you.
He's the guy whose angle got shut off.
I got my rock and roll going on here. Explain how each part of the formula relates to the sequence. Well, I'm adding 3 and you start at 5, okay. I don't know who Achille from Johnny is, so we're gonna skip Johnny's formula.
What, Johnny, what?
All right,
What's Johnny's?
now let's talk recursive.
John Warner?
Oh.
Can you write out the first 5 terms of this sequence?
Oh, which one?
The one on the left.
The first one?
Write out the first 5 terms of the sequence, the one on the left.
-1, right?
Wait. A sub 1 equals 8?
One on the left.
Plus 3. B plus 3. 19.
What? I don't get it. I don't get it.
Okay, so, I like recursively defined sequences. What we did in the beginning of class is what we call explicit formulas. Explicit formulas are excellent for telling you which term is in a sequence. Okay? What do they do?
Tell you which
Tell you which term's in the sequence. If I say I wanna know the 25th term, I wanna know the 10th term, I wanna know the 144th term, those are all, explicit forms are great for that. Recursive forms are great ways, Noah,
Recurring.
to write the sequence, okay? It's literally a set of instructions. This is saying the first one is 8. Then it's saying the new term is the previous term. See, n minus 1 always comes before n in the sequence. So in your mind, you need to read this properly. Now, remember, I said that if my dad said, Robert Carl Lindquist Jr., it meant the meetings were about to begin. There was code within that word. Here, there's code within this. Yes, it says a sub n is equal to a sub n minus 1 plus 3. But what it's really saying is the new term is equal to the term before it, the previous term, plus 3. So this is a guide, a path to generate the formula. First is 8, what do you do to get to the next one?
You add
11.
3,
11, next.
14,
14, next.
17, 20,
And so on.
23,
Wait, I thought you
Now.
have to go pick one back.
I'm sorry?
I thought you had to like go back.
That's what I thought.
No, and let me explain now the next one, ready?
Oh, my eyes were
A sub n plus 1 will always be the term after the a sub nth term.
What? So 9?
In other words,
Oh, I get it.
let's watch.
So I like it.
Everybody talk less, listen more. Watch. The first term is a sub 1, the next term is a sub 2, the third term is a sub 3. And then let's go all the way up here to a sub 1000. Somewhere in the middle is this term a sub n. Somewhere in the middle, whatever term. What's the term after this?
A sub n
A
plus
sub
1.
n plus 1.
And what's the term before it?
A sub n minus 1.
That's right. So do you see how a sub n comes after a sub n minus 1?
Uh-huh.
Yeah.
So that means that if I think of it as in terms of a sub n, then a sub n minus 1 is the previous term. So here's, if I think in terms of a sub n, then the previous term is a sub n minus 1. So the new term is the previous term plus 3. Now, let's look at it from the perspective of a sub n plus 1. What comes before a sub n plus 1? A sub n. So I could say the new term, thinking of this guy, is the previous term plus 3. Now, if we carry that to its broadest understanding, a sub n represents any term. So what this is really saying is, for any term on the face of the earth, the new term is the previous term plus 3, according to this recursively defined sequence. So the first, a sub 1 tells you where to start, and then this tells you the rule. Add 3 every single time. Okay? So let's think of a recursive formula, 2 of them as a matter of fact, that can define this. Now, what does every single recursive formula always start with? A sub 1. What is a sub 1?
3. A
3.
sub 1 equals
So
3.
a sub 1 is 3. Now, the first form of this will be a sub n equals, and then over here I'm going to put a sub n minus 1. In other words, the new term is the previous term. Now, what do I do to go from term to term to
Times
term
two.
to term?
You
Times two.
multiply the previous term times 2.
That's it, yep, and that's it.
So you minus what?
Oh.
You're not subtracting
I'm so
anything.
confused.
I
So the next term is the, oh, okay, so.
Again, let's read this properly. The new term is 2 times the old term. The other one, guys, is this. It's the same thing, except I use the other notation. Okay? Hasta la vista, vaya con Dios, toodaloo, ta-ta, arrivederci, smile out, ciao, arrivederci, adios amigos, amigas, cheerio, gadoosh, Gadafis, shalom, sayonara.
Hasta la bye bye.
That, good one.
I hate each
Oh,
and every one of you.
what did you say? Oh, for the phone, okay. Yeah. I thought I had a new one for my list. Yep, you too, enjoy.
Is anybody else in the other class get 100?
No, you were the only 100, but we did have a 99 in the other class. And
Who was
maybe a
that?
98. There were, in each class, there were some very good grades. Did you see your mistake, Ellie?
What?
Did you see your mistake?
What, did I write, like, is the range?
I forget what,
I wasn't sure on that.
yeah, range is always Y.
Oh, okay, yeah.
Wait, oh.
You said for the last one.